And continuing with the rebuild on the 4D56U block or engine, turbo diesel, and we've got 131 kilowatt. There is another version, the two-wheel drive one, which is 100 kilowatt. So we've had the block at the engine reconditioners. They've given it a good clean. They've bored out the cylinders 0.5 of a mil, and they've surfaced that where the head sits on there 2.5 thou. I just got them to just clean it up. We did check it with a straight edge. It wasn't too bad, but there's little pitted marks where the water ports are, so you can see that they're still there, but it's not too bad. That will seal adequately enough for us to continue the job. So now we've bored out the bores 0.5. You got to make sure that you order pistons and rings that are oversized by however much you have bored it out. Now it's a good idea to check all the rings in all the bores, just make sure that everything's been done properly. We've already checked these. The bores weren't too bad anyways. Now with the rings, you'll notice there's a thicker one. The thickest one goes at the top. That's the number 1 compression one. But you'll notice, I don't know if you can see that, it's actually tapered. The flat end goes to the bottom. I think it's that one with the number, that there's a little number on this particular brand of ring. That one goes to the top. It's the top one. You've got your middle one. And you've got your bottom oil ring. Good idea to test them in the bores like I mentioned. Careful you don't damage the ring when you're putting them in. You put them in nice and evenly, like so. You can use a piston to just make sure that the height is the same all the way around, like that. And then basically you use a set of feeler gauges. So these are 3.5 inch pistons, or close to. General rule is 3 to 4 thou per inch. So 3.5 inches times that. But because this is a turbo diesel, high compression head, it's probably, I've been recommended to leave a gap of between 4.5 and 5.5 thou per inch. So we've measured this and we've got about, that's 20 thou clearance. So that just fits in there nice and tightly, see, like that. And we'll check all them like that. 3,575, 3 inches and 575 thou, and we've got 20, right on 20 thou. So we got 20 thou divided by 3.675, and we've got basically 5.44 thou per inch. So that's within the specs, recommended specs, 4.5 thou to 5.5 thou per inch for this particular motor. So it's a good idea to check all your rings first. Check all your bores, check all your rings, check all the gaps in the rings. Sometimes you might find that a particular set of rings fits better in a different cylinder. It's up to you to decide that. These are all the same, so we've gone through, checked them. Because they've surfaced the top of the block there, you'll find that there'll be very sharp edges there, especially on the water ports where they are. So what I do is I've got this scraper, we just go around and just take off that sharp edge. You don't want that chipping off along the way and falling in the water ports. The oil ports aren't so bad, but it's a good idea to do them as well. Just take that sharp edge off, just put a slight chamfer, blow the whole thing off, and away you go. Now, a good idea is to just make sure everything's nice and clean. You want to, because we've been waiting for parts for this, so it's been sitting a little bit. So we've coated everything in WD-40 just so it doesn't get any surface rust on anything. Just make sure it's all nice and clean and covered. You can see there's a little bit of engine oil there. So we've got our main bearings. We're going to put those in. Put in the lower halves. Now when you put these in, you don't just slide them straight in, because what happens, you can end up scraping a little bit of that metal there, and then it causes the bearing to not sit properly in the journal. So what you do to put them in, you'll see there's a little pin there, and that'll just locate in that slot there. But when you're putting them in, you actually squeeze them a little bit, just so it slides in a little bit easier. There we go. Got one in. You'll also notice, if you feel with your finger, that bearing is sticking up a little bit higher, and that has to be a little bit higher, so when you clamp down the other half, that bearing can't move. It's called crush. You got to have that bearing nice and tight in there. Put it in, and you just sort of push it in just so it slides in, it doesn't scrape its way in. Now we've got the old original crank next to the brand new crank. You can see number 1, big end bearing's gone. Number 3 and number 4, you can see number 1 spun the bearing completely. There was no bearing in there, and these look like probably a lot of that rubbish circulated through and caused damage to these. Now it's important to just double check that everything's the same, just in case. You can also see where the rear main seal runs. It's actually worn a groove in the original crankshaft. Now the way a crankshaft gets lubrication, they come through the case or the block. They come first through these main bearing journals, and then what happens, it actually lubricates the big ends, or the Conrods. So the way you can see that, here's the front of the crank. If I poke that through there, you'll see that it's come out from that angle there. So that means that the oil's coming from here and then lubricating that number 1 there. On this one, it's going to number 2. And you've also got another hole that just goes straight through. And you got this one, which is the main one. You got your thrust bearings sit on that one there. You can see that nice smooth surface. Then you've got this one, where you can see it's lubricating that one. It's sort of like it's in 2 halves. You got your front half and your rear half is for the lubrication. The rear one as well, you see it goes right through, and that one will go to number 4. Now if you read on the technical information on high performance racing, what they do is they actually put a little slot just straight across there on these bearings. The reason why they do that is because when the oil's coming through here, through the main bearing, through that port up to here, there's only one lubricating port on this one. So what that does, it'll lubricate when that bearing has come away from there. It'll shoot a film of oil in there. But what happens as that spins around, someone's actually calculated that 180 degrees of that journal is running dry for a period of time. 180 degrees of it until it comes back down again, and it just keeps going like that. So by putting a slot in there like that, you actually reduce the 180 degrees, so you extend the life of the bearing by increasing the lubrication. Hope that makes sense. Now I'm just putting a little bit of assembly gel on those thrust bearings, just so they stick in place and don't fall out while we're putting the crank and possibly pulling it out again as well. They just sit like that. Little bit of squirt of engine oil. And we carefully put the crankshaft in. Just be careful you don't knock those thrust bearings out. That's better. Made it into a 4.5 cylinder. We can give that a bit of a turn just to coat everything. That should spin nice and freely. Should be able to just give it a bit of a spin like that. So now we're on the website where it shows all the specs for the torque settings, and we've got the bearing cap bolts, or the main bearing cap bolts. You've got 40, what's that, Newton meter, is it? Yeah. 40 Newton meter plus or minus 2, plus 35 to 39 degrees. Now we're just going to put the remaining bearings in there and tighten it up. Make sure you lubricate the thread as well before you nip them up. Now when you're putting the bearings in, it's important to not scrape that bearing or the back of the bearing with that sharp edge there. The way you're doing that is you're trying to crush it or squash it in like that so it's not scraping on that edge. So you put the in there like that, and you're pushing with your thumb that way, and it'll just slide in nicely like that. Instead of just pushing it in, you'll end up scraping a little bit of the back of the bearing, and it can sit under the bearing. You want that bearing sitting perfectly on everything there. And the lucky last one. Got to make sure it's spotless under there. Okay. And I'm pushing it that way and down. It's going in a bit crooked. There we go. And there's also a little bit of the bearing sticking upwards like that. That's a crush. It's called a crush. It puts a load on the bearing, so it's nice and tight, like it's one full bearing. A couple more drips of oil. The caps should be numbered. So you got number 1 with the arrow pointing forward. Number 2. Number 3. And this one's where you have those thrust bearings as well. Number 4. And lucky last, number 5. A little bit of oil on the threads. Now when you're tightening them up, because there's that, if you remember, that nice sharp edge on there, you do up one side up to it and then the other side, and the idea is to try and get it to go in nice and parallel. You don't want to damage that little sharp edge. That sharp edge can actually chip off sometimes. So I've done all these up just with the speed brace, as hard as I can with the speed brace. And that should still spin nice and easily. I haven't torqued it up yet, but it's a good idea to give it a bit of a spin just to coat that bearing with that oil before you nip it up tight. So we've got 40 Newton metre, which is basically 30 foot-pound apparently on the conversion chart. And we just adjust that up and we can tighten them up. Now I've only done it to 30 foot-pound, and now we've got to go another 35 degrees. So we've got our little stop there, put that up against the crank, adjust this to 0. And we go 35 degrees. Oh. 35. And each time you tighten up one of these caps, it's a good idea to just see if you can turn it nice and easily. So we've done the middle one. Now we can just go from front to back or back to front, it doesn't matter. We're not tightening the head here, but it's important to do one cap at a time, not do one side and then the other side. So again, let's hit on there, put it on 0. $35. $35. 5. All nipped up. You can see I can still turn that nice and freely. Now that we've tightened it all, now comes the interesting part to see how much gap we've got in there. So we're going to start at number 1 and we're going to put some wax in there and just measure how much gap we've got in that bearing. Okay, take that cap off, and now we've got the Flexi-Gauge. So what it is, it's a little thin piece of wax you put across there, tighten it all back up like we just did, and then you can measure how much gap you've got there. Over here you'd have, if it flattens it out to there, that's 1 thou. You've got 1.5, 2, 3. This one's the green, which is the 1 to 3 thou, and you've also got the red one, which is 2 to 6 thou. So we're going to start off with the 1 to 3 thou. There we go. I've got a little piece of wax there, the green. You put it on that way, and now we bolt that end cap back on like we did before, and that'll flatten out that little piece of wax. Make sure you're facing the right way. Don't turn the crank, because it's going to smudge your wax as well. And it's a good idea to do it one at a time, because it's holding that whole crank in its natural position. We'll tighten that up just till it's up to it, and this one up. Adjust it up to 0. To 39 degrees. Okay, I've tightened it all up. We don't spin the crank. Now we loosen it again to see how flat that little wax is. Now you can see the wax in there, if you can see it, and there's also a mark on the crank. Now the one little boo-boo I've done, you can see it's got that groove in the middle. I should have put it to the side a little bit, just so it's not in the groove. But you can see how wide that is there. And there's also a mark in there if you can't see it. It's a little bit hard because the light's shining on there. And we've probably got, I'd say 2 thou. It's as wide as that little green mark there, where my fingernail is. So we know we've got 2 thou clearance in that bearing. We're going to go through and test them all like that, and then we can go and do the same on the big end bearings.